Okay, so let's get started. We're going to do some naming. Okay, so what's the first thing you have to do? Parent chain. Yay. So let's do the molecule on the left. Figure out what the parent chain is. How many carbons in it? 8. Which 8? There's 3. So definitely have to start.
Left, top left.
Yep. Oh, wait a minute. Okay, so my computer is doing something funny. It's actually not funny. I am. Weird. Okay, I gotta stop something. Now let's try this again. Yeah. So 1, 2. Well, that's not necessarily the end we count from, but it's very clear that this is part of the longest chain. So we can just count here: 1, 2, 3, 4, 5, 6, and then I can get to 8. I can go 7, 8. I can go 7, 8. I can go 7, 8. One of the down ones. Does it matter? No, it doesn't. No. Yeah. Sorry.
Why does it not matter?
I'll show you. 1, 2, 3, 4,
Highlighter.
5, 6, 7, 8, right? So on the 2 carbon, if I count from this direction, there's a methyl, right? If I count from this direction on the 2 carbon, there's a methyl, so it doesn't matter. Okay? It doesn't matter. Okay, so that's what I'll do. I'll just choose to go that way, and then I'll put the numbers. Numbers are going to start down at the bottom.
Wait, how come you started at the bottom? I started at 8. I did it backwards.
Ah, that's a good question. If you started at the top left and counted, you would go 1, 2, 3, right? First substituents on the number 3 carbon if you go that way. If you count the other way, the first substituent's on the 2 carbon. You want to give it the first substituent the lowest possible number. Okay. Good. So, go ahead.
The first substituent, the lowest possible number?
Yeah. Okay, so on 2 and 3 and 6, right? What do I have that's the same? I have methyl. 2, 3, 6. I have 3 methyls, so that would be what? Trimethyl. Now, this is not necessarily order of the name. It's just I'm writing the substituents down with their locants, and then what? 3. What's that group? The other group there. This one. That's an ethyl, right? Now, the parent is octane. So I'm going to write octane over here, and then we'll organize this. Okay, so the parent's octane. What order do they go in? The 3-ethyl and then the 2,3,6-trimethyl. We alphabetize on the M here and the E here. Okay? So now all I need to do is figure out how I'm going to make this thing move. And put them in order. Oh, I lost something. Trimethyl octane. Not sure what happened. I don't know where that little piece came from, but it came from somewhere. So 3-ethyl 2,3,6-trimethyl octane. Okay, let's do the next one.
Wait, and that's the whole name?
Yeah.
That was gonna flow. Yeah.
What?
I thought it was gonna flow nicely. Yeah.
It did. It does flow nicely. What are you talking about?
1, 2, 3, 6 trimethyl octane. That's the.
Yeah.
Sounds like spaghetti. It's all messed up.
It's like Prince changed his name to a symbol.
Spaghetti. It's all messed up.
Okay, you know, that's actually normal there. Okay, so let's do this one. What's the parent? The ring, right? I have a chain and a ring, and the ring's bigger. Some people will love to go and they love to count from here. 1, 2, 3, 4, 5, 6, 7, 8, 9. Because they think, wow, that's the longest chain, but you can't count through or go into a ring and then count out of it. So you have to have a chain or a ring, and you can't have a combination of the two, so you can't count through the ring.
Once you've gone into a ring, you can't.
Yeah, when you count carbons for the parent, you can only count the ring and not the substituents that are stuck on it. All right, and the substituents you don't count, like this is a butane, right? You wouldn't count butane and then continue to count through the ring.
There's like 2 rings attached. Did you go through one and out one and the
Oh yeah, so so it's 2 rings attached. The bigger ring is the parent, and the smaller ring is the substituent. Yeah, so like what you're talking about is if I had something like this, right?
What if you have like 2 benzene rings?
Oh, that's called biphenyl. It's got a different name, but yeah, you would call it phenylbenzene, I guess, systematically. A benzene ring's called a phenyl group.
So say you had a chain attached to the ring that was longer in carbons than
Yeah.
the ring is. Does
Yeah.
that make it the ring?
That makes the ring the substituent. Yeah, that's the rule I'll follow. Actually, people don't follow that rule very well either way, but that's the rule that I'll follow. The other thing that happens is if you have a ring and the chain, let's say they're both 6 carbons, we pick the ring. Okay? Yeah.
You said there's just to reiterate what you said the chain is longer.
Chain, yeah, whichever one's longer has the most number of carbons in it. Okay, that's the parent. But if it's a tie goes to the ring. Okay, so never mind. I had a weird analogy, but I decided not to say it.
Probably for the best.
Yeah, probably for the best. You could ask me later, but it's about relationships and then how do you break the tie? You break it with the ring. Sorry. You guys can put together the rest of the perverse stuff in your head. Whatever. So this one would be cyclopropyl hexane. So back on the problem. What's this, parent? How many carbons? It's a heptane, right? Yeah, so 1, 2, 3, 4, 5, 6, 7. Okay, it's got a heptane. Now, I got to number these. So you notice there's 2 ways I can number this. I can go 1, 2, 3, or I can go 1, 2, and 3. The question is, which one of those is correct? Now, in a ring, the second substituent, you want to have the lowest possible number, but in this case, it doesn't matter because anytime they're all adjacent to each other, it doesn't matter which way you count. I'll give you a hint. These are ethyl, and that's butyl. Start with the butyl. If there's a tie, again, you go to alphabetical order.
So isn't butyl bigger?
Doesn't matter that it's bigger. Alphabet. B becomes before E. And so if there's a tie in the numbering, counting either one way or the other, then you just break it alphabetically. And if there's a tie then too, then it probably doesn't matter which way you count, because it's probably the same groups. So for example, if you had something that looked like this, a little spaceship, right? This would be an ethyl, methyl, and an ethyl, right? So it doesn't matter if you count this way or this way. Right? You'll start with an E either way. Got it? Okay, so the name for this one would be 1-butyl. And then 2,3 diethyl cyclo. Don't forget cyclo. Lots of people forget cyclo. cycloheptane. And then they kicked themselves afterwards because they for sure knew that they were supposed to put cyclo, and then they forgot.
So cyclos for anyone that isn't a
Ring.
Hmm?
Cyclo just means ring.
Yeah.
Any ring.
It's a general term for
Well,
ring.
but
Any alkane that's a ring is cyclo.
is benzene just with a double bond in there? Is that-
Yeah, benzene's the special case. Benzene in the IUPAC nomenclature has its own name.
Okay.
If you were to name it systematically, benzene is a triene, right? And it's an alkene, so we would actually call it 1,3,5 cyclohexyl triene as a systematic name. But anything that's a ring has cyclo in it, unless like benzene has its own special name in the own place in the IUPAC system. Okay, so good. Oh, I forgot. I was going to answer questions on homework. You has to stop me. All right, so what we have to do is also name some branch substituents. Now, this branch substituent, right? This is the parent, clearly the longest chain. This branch substituent goes 1, 2, 3, 4, and it has 5 carbons on it, right? So then we have to decide how we're going to name that. Typically what we do is this. Where the substituent is attached to the parent, we number that carbon 1. And then we count the longest chain. And now go ahead and name that as if it wasn't attached to the parent and that was the number 1 carbon. So that one would be 2-methyl, right? Butane. Now, how long's the actual parent chain though? We have 1, 2, 3, 4, 5, 6. It's 6 from either side. So what's 11? It's 1 and 10. So it's undecane. So the name of the substituent is the same as if you were to say if it was a butyl group, right? So you would go, because if you were ignoring this part and it was just the 4 carbons, it would be 6-butyl, right? Undecane. So all you do is you create a substituent out of this by just changing the name to 2-methyl butyl undecane. Now, the only thing that's missing is you have to tell people where that substituent is. And it's on the number 6 carbon. What's confusing is sometimes when people will leave the parentheses off, so you don't know where, like it's hard for your eye to see where it is.
Would you just technically look for the YL?
But you just look for the YL, that tells you where the substituent is. But I love putting the parentheses there because it's a little easier to see. Okay. Now, some branch substituents have other names. So I'm going to show you some other names. But first of all, I'm going to teach you a little bit about classification of carbons. So let's say I have a parent chain, and I'm going to say R is equal to the parent. So we don't have to think about what the parent is. Okay, so let's say I have a group that looks like that. That's a primary carbon. That's a secondary carbon. And that's a primary carbon. Give you another example and see if you can piece together what it means. That's a secondary. That's still a primary. That's a tertiary. What do primary, secondary, and tertiary look like they mean? It does look like that. No, it doesn't mean that. It doesn't mean first, second, third.
Primary means it can be the first. The branch.
Okay, hang on.
That's not it.
If I do that, that's also a tertiary carbon. And that's a primary.
Oh, when it's on two different groups.
Yeah, it's the number of carbons it's attached to. Okay, so this is a primary carbon, okay, because it's attached to one other carbon. This is a secondary, ignoring the R group, okay? The R is just the parent, and the parent has a carbon on it, but we ignore that one. This one's a secondary carbon because it's got a carbon this way and this way other than the parent. Oh, it froze on me again. Interesting. My little router's okay, but it keeps locking up on me. Yeah, I disconnected again. Okay, so then here, oh, it came back. Maybe I just need to do that more often. So, oh golly, it's gonna make me crazy. It's stuck again. We'll leave it alone. Right, so this one's tertiary because it's got 1, 2, 3 carbons on it. Okay. So now, ignoring what's there, and right on the board. I know, so sad. My thing's frozen up. I don't know why. So 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we do that one again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And I'm going to go 1, 2, 3, 4, 5, 6. I'm going to go here. Missed. Okay. What is this? It's a butane, right? So, oh, and then in terms of carbons, it's a butane. So connected to here, okay, that's a secondary carbon, right? So this is known as a sec-butyl group.
Why is it secondary?
Because it's on the secondary carbon.
Wait, can you say that one more
Wait.
time,
But you just showed us that three, there's three tertiary.
Right. But this is the parent, right?
The R.
The R doesn't count in the counting. Okay? So if you just ignore it and you look at how it's attached, this is a sec-butyl group. On the other hand, if I take the same thing, go like this, so this was sec, right? What's this? So what kind of carbon is that? Ignoring that.
Tertiary.
It's tertiary. So this is tertiary or tert butyl. So again, these are very common ones that you need to know based on what IUPAC tells us. The abbreviation for this is T-butyl. So you'll often see it as T-butyl. Sec-butyl, you almost always see it as sec-butyl, but tert-butyl or tertiary butyl, you almost always see it as T-butyl.
Why is that one T-butyl and not T-propane?
Good question. How many carbons are here? I know, but that's why it's kind of a common but accepted name for IUPAC. It's based on the total number of carbons, and there's only one way to do a T-butyl. And if you think about it, this is the one that I keep drawing like this. Right? It looks like a T. Right. Yeah, so we found out yesterday my uncle's pump, who supplies water from my mom's house because my mom's well went dry. That one broke. We had no water on the farm. So it's on today, and then my mom's other issues, old issues. I'm just leaving my phone on. So sorry about that. It's distracting. All right. So there's another classification of names. Let's see if you can figure it out. Put R here. Okay. This is propyl. You know that one. This is known as iso. Now let me do this. So this is isopropyl. This is known as isobutyl. I'm going to draw a bunch of them that are isos. This is not iso. What does iso mean? Single branch at the end. So this is what? Isopentyl. So these names are based on the number of carbons total in the side chain. So this is isopentyl. Right? And guys, what's the alcohol being used in the lab today? Isopentyl alcohol. The common names, these are often used for common names. Isopentyl alcohol looks like this. Because it's an isopentyl group with an OH attached to it. Isopentyl chloride, that's a common name, would be an isopentyl group with a chloride attached to it. All right. Don't know why. Oh, did it work? Oh, it worked finally. I still have something stuck up here, but okay. Skip over some of this. For 5, we could do isopentyl, but there's another isomer that contains 5, and it's this one. So it has, this is like a T-butyl group, but you've added one more carbon. So this is, like, think about the way they went about naming these. Oh, I had a pentyl group. Oh, I had an isopentyl group. And then I have another one, like the new isomer. So this is neopentyl. Okay. Now that I've told you that, I have to tell you there's 2 ways to name these. Oh yeah. But remember I taught you, I didn't teach you that one. Yeah, amyl means 5 carbons. Yeah. So, but that's a common name, not a systematic name. So let's say it looks like this. And this is the substituent off of the parent. What do we learn to call this so far? T-butyl. Now, if you want to name this systematically rather than having memorized that name, okay, then if you do it systematically, you count this is the 1 carbon and this is the 2 carbon. So then it becomes 1, 1. How many methyls, right? Dimethyl. Then what? Ethyl. It would have been an ethane if it had been a... Well, it wouldn't have been an ethane if it had been a compound. It would have been propane. But if you were ignoring the fact that it was connected to this, it looks like an ethyl group. Now, there's yet another way to name this. The other way is to number it like this. 1, 2, 3. And then in this way, what you're doing is you're telling people, because there's no numbers in here actually, what you're telling people is connected to the number 1 carbon. I'm counting directly from the number 1 carbon. The other way to do it is number the longest carbon chain that's attached, and then tell people which carbon attaches to the parent. So to start with, the substituent is a methyl group, so you're still going to say 2-methyl. And what's the long chain in this? It's a propyl group. And then you're going to add the number in the middle to tell people it's a propyl attached on its number 2 carbon as a substituent. That's what the YL is telling you. Okay. Those are all acceptable names for that. T-butyl is by far the most common way that people will think this. I don't know actually many people who do a lot of organic chemistry who would say 1,1-dimethyl ethyl. They all know it, but they're like, why would you write this or this when you could write that? So isopropyl would just be, right? Prop 2-bil, because it's 1, 2, and 3. What would you name this? It doesn't have a simple name, so then you have to name it. Right, so it's not iso because this is on the wrong end. For iso, it has to be on this end. So this one, because it doesn't have a simple name, you actually have to go through and say it's 2. So 1, 2, 3, 4. It's 2-methyl butyl. Yeah. So this 2 is referring to connected at the number 2 carbon.
To the R, right?
Yeah, to the R. So this number in the parent name is saying this is where the parent is attached. Sorry, this number in the parent of the substituent is telling you where it's connected to the parent.
And then because on the 2-methyl butyl, because it's connected to 1, it's already assumed.
It's
that's
already
there.
assumed it's on the
So you
1.
don't need to put the 1
Right.
between there.
There's one other one I wanted to do. What was it? Probably not on my slides. This is still being recorded, I think. Yeah. Okay. I'm not writing on here anymore. Okay. Seems like every time I touch my iPad, it freezes on me. Let's see what happens when I go a few slides. They go through systematically in the slides naming everything. Now we want to do bicyclic compounds. All right. So we're talking about what are called fused ring systems. This is a fused ring. It has a 6-membered ring. This is known as a bridgehead. Just like if you were to walk on a regular, like a standard bridge, the things at the ends are known as the bridgeheads. And this is the bridge. In fact, all of these could be considered to be bridges between the bridgeheads. So this is a 1-carbon bridge. This is a 2-carbon bridge. And that's a 2-carbon bridge. This has how many carbons in it?
6 plus another 1.
Yeah, so 7, right? So this is known as a cycloheptane because it has 7 carbons in it. But it's going to have a difference in the name. There's 2 rings, right? So we call it a bicycloheptane. So the basis for the name of this compound is based on the total number of carbons in the compound. So this is a, let's see if this works and doesn't die. This is a bicycloheptane. Okay, but look at this one down here. Oh, and this is just another way to draw it. This is as if you're looking from the top, okay? And you're just looking down, and you have a little perspective, and that's why you can see this one pointing out to the right. On this one, what they've done is they've taken the molecule, you're looking at it like this, and you have to imagine there's a bridge pointing at you, and then they drop it flat. So now you're looking at it as if these 3 carbons are in the front, and then these ones are all in the back, and this one's on top. And part of the reason you can tell that is because when the line crosses, they blot out the line in the back to show that it's going in front of. So that's to help give you some perspective on it. So these 2 are the same, but you could also connect this carbon, instead of to here, you could connect it to here. And when you do that, what happens is you get this structure here. But that's also a bicycloheptane, right? So this is the one that's directly above here. This is connected at a different carbon. So if you're going to do nomenclature, the role of nomenclature is to have unique names. So bicycloheptane can't be the only thing we tell people. Go ahead.
I'm going to try my best to word this. So you name it heptane based on the ring having 6 points.
Yeah, all the rings being 7.
All right, there's one. Oh, heptane.
So you're counting all the carbons.
Okay. Never mind.
Okay. So yeah, so we count in the naming of bicyclic or tricyclic or anything like that. You name all the carbons, and then what you do in order to make these distinguishable from each other, you tell people how many carbons is in each bridge. So you start with the largest number. So how many carbons are in the largest number for this structure on the right? There's 2. There's 1, 2 in that bridge. How many in here? There's 2, and then there's 1. So this one would be 2, 2, and 1. That's what you would tell people. Okay, I'll show you how to format it, but that's how it's named. What would this one be? 3, 1, and 1, right? So that distinguishes it from the other one.
Where's the bridge?
So the bridges, okay, these are the bridge heads. Let me shade them in just for funsies.
Colors, please.
Colors. Those are the bridge heads, okay? Here, the bridge heads are here. The bridges are everything that go in between them, okay? So you have 3 bridges. You have to tell people how many carbons in each bridge. So that's where the 3, 1, and 1 come from for the one on the left bottom, and for the one on the right bottom, it's 2, 2, and 1. So this is how you format the name at the bottom. All right. You would say, you can't really see it, so I'll write it again. Again, the name is bicyclo. Ooh, can't write with that. And then a bracket, and then you would say 3, 1, and 1. And then it's a heptane. So these are the carbons in each bridge. And they're in descending order. Not that that matters that much, but they're in descending order. So on the left, it's 1, 2, 3, and then 1 and 1. So these numbers represent the number of carbons in each bridge, right? These are all bridges. This is a bridge, this is a bridge, and this is a bridge. So that's where the 3, 1, 1 comes from. So the one on the right, oh, go ahead.
Are both of those 3, 1, 1, or are they 2 different?
No, the one on the right's different.
Okay.
It's going to be bicyclo. Say it again. 2,
2, 2, 1.
221, yeah. It doesn't matter that much, but there are actually periods, not commas, in between. I don't know why. And then it's still, bicycloheptane, yeah. Got the bicyclo in there. Okay. Now, we got to number them. And what you do when you do the numbering, there's two rules. The first rule is count the largest bridge first. Okay? Count the largest bridge first. So in this structure, right, this bridge is the largest. So you start at a bridgehead. So bridgehead will always be number 1. But there's 2 bridgeheads on this structure, so you can count from either direction. You can count here, start here, and count in this direction, which turns out to be the correct way. Or you could count starting where the 5 is here, that's this one, and you can count in this direction. This one's incorrect. Why do you think it's incorrect? Oh, sorry. Why do you think that's incorrect, the one on the right? Because the substituent number is a 7 instead of a 6. So the second rule is, without violating rule 1, okay, give the substituents the lowest possible numbers. So rule 1 is start at a bridgehead, count the largest bridge first. The second rule is give the substituent the lowest possible number.
Over these compounds.
Yeah. So, but why do they say without violating rule 1? Because if you start at the bridgehead and start counting this way, you could make it 2, right? And you'd be like, oh, I'm all happy. That's 2, because that's kind of what we teach you for everything else. Right, lowest possible number. Start at a bridgehead. That's wrong because you're violating the first rule, which says start at the bridgehead, one of the bridgeheads, and then count the largest bridge first. Okay. So in this case, when you do bicyclic compounds, the substituent may not have the lowest possible number if you violate the first rule. Anyways, I think I said that kind of right.
I still don't understand when you say count the biggest bridgehead first.
Yeah, biggest bridge. Start at the bridgehead. That's where they join.
Yeah.
And then count the largest bridge. That's the part that goes around. So if you look at this, is great. If you look at this, right? This has 3 carbons in it, right? This one has 2. This one has 1. So you count this one first.
Oh, okay. Oh, and then that one didn't correct because it went the other way than the 7.
Yeah, yeah. It still has to go this way through the 3 carbon bridge, but because you went this way, you ended up with 7 on the carbon, on the methyl group. Okay?
If there was no methyl group, would it matter?
Well, no methyl group, it doesn't matter. And the smallest bridge is going to be 8. So what is the name? So it's a, what is it? It has 8, right? So what is it? It's an octane, but it's a bicyclo, right? So let's start with the name of the parent. It's going to be bicyclo 3, 2, 1. Octane. So that's the parent. And the substituent is the methyl group, in which carbon is the 6, right? So it's 6-methyl. So now if you just put it together. The 6-methyl goes in front. But the first thing that you do in nomenclature is you always name the parent. You establish what the parent is, you number the parent, and then you find the substituents, and then you put the name together. In alphabetical order, but there's only one.
It's not the bicyclo.
It is.
It is. But that's the first thing that I'm just doing it in the order I normally do it in. First thing I usually do is establish what the name of the parent is. This is the name of the parent. Right? I haven't put the name together yet. To put the name together, I would take the 6-methyl and go like that. 6-methyl bicyclo 3, 2, 1 octane.
Oh, that makes so much sense. Because if you put the 6, then you know where it's coming out from on the parent ring, right?
Yeah.
I know, sorry, I just had like an epiphany. How do you have this number?
What the heck is that number? Yeah, very good. For really large, I don't even have to do this, I suppose, but for really large molecules, we just give them names like Nexium. This is the systematic name for Nexium. You don't see anybody going to their doctor saying, "Oh yeah, man, can you refill my prescription of S5-methoxy-2 bracket parentheses 4-methoxy-3,5-dimethyl pyridinyl 2-ill parentheses methyl sulfonyl bracket hyphen 3H benzoimidazole
Sorry, what was that?
Nexium." And the doctor will be like, "Oh yeah, of course." My mom puts me through this all the time because I do her medications for her, and she was a pharmacist. So she's like always using either the trade name or the actual drug name, the trademark name or the generic name, and I'm like constantly having to go like, "What is that? Are you taking that? No, you're not supposed to take that." So they go look it up and like, "Oh yeah, you're supposed to take that. Never mind." Yeah. I guess I'm done. I ran out of time. But that was fun.